Mr. Piyush Pandya, who is currently working as Senior Vice President, South BU, IndiGrid, comes with over 26 years of professional experience in power generation and transmission sector. Mr. Pandya graduated with a Bachelor of Engineering and has also completed Masters in Human Resource Development. He is also a certified energy auditor and Six Sigma Green Belt holder. Previously, he worked with various utilities like AEC, Reliance Infrastructure, and Aparva Energy. Mr. Piyush will share his inputs on the role of digital intervention in driving efficiencies and effectiveness. So, let's welcome Mr. Piyush Pandya.
I would like to share perspective from utility perspective, right, to digital intervention, which could really drive efficiency, productivity. And so we would like to share about the utilities perspective on the digital intervention that is available for a substation as a sector, and also highlight a few of the examples where realize the efficiency and effectiveness along with productivity. So starting with what we feel now is that digital technology is not luxury. Now it is a very essential part of complete asset management. And in that case, at IndiGrid, we had like an asset management framework, which talks about shifting our approach from a conventional preventing type of maintenance to reliability-centered maintenance. How to achieve it? I think that could be achieved only with the help of digital technology that is available now. And it's a proper application, and that will help us to achieve our goal of zero harm, superior availability, and highest reliability of our asset. And from that perspective, I would like to have a digital intervention for substation in three parts, three buckets. Few of the interventions which are directly related to the asset management approach and practices. Some will be another aspect, or another bucket will be like sensorization part of it. What kind of sensor are there available and how we can utilize it better. And third part is on the some kind of a design aspect, which is very, very important if it has been taken care at the planning stage. So coming first on that part, digital asset management is basically nothing but implementation or digitization of all our assets, whether it is a transmission tower, it is substation equipment, or solar asset, so that each and every asset is been digitized, and then it is been with the help of this mobiles, notepad with feature like geofencing. Now we are carrying out all the inspections, surveys, and O&M of the complete network. The benefit we are really getting is in terms of productivity, traceability, and control of data, which earlier was something we were struggling to, right? So I think this is very, very important step, and which can be utilized by every utility. This becomes now a foundation block, and more top on that, we are also working to have like a analytic tools, which may be available, and we had implemented few of that, so that our majority inspections and maintenance what we carried out provide as a meaningful informations. And based on that, we taken certain decisions about taking out the element for the maintenance, retrofit, and also addressing the obsolescence issues. Going future, I think it will be like we wanted to build some kind of a more advanced tools, which is very helpful in terms of assessing the health of the equipment. And particular substation has a very, very costly capital equipment, and they are revenue generating element. If I take an example of a transformer, which is a very costly equipment, and almost utmost importance is given to ensure that it is remain healthy, operating at all time. Now, if we talk about transformer, it's just like a black box, and we have to ensure its healthiness only through some of the inspections, some of the tests, electric tests we do. But for each of that, there is a various data points that is coming out. How to trend it, how to monitor, and how to make meaningful assessment of this data. I think in that case, for each equipment, and when we talk about a portfolio size of 70, 80 transformer installed and operated across geography, it is very, very difficult task manually to train and plot all these informations and arrive at decision making. So I think in that case, nowadays, various OEMs and other utilities has come out with a asset health index kind of a solutions platform through which we can input all the data. This data may be directly from manual intervention. This data can be from SCADA. It could be from sensors. And then in terms of output, it provides health. What is the current health of the equipment? What is the probability of failure? What could be the recommendations to address any abnormality that is developing inside? The idea is to, number one, to get an assessment about health and going to the reliability-centric maintenance, where we cannot fix the schedule of maintenance at this point of time, but based on the health of the equipment, we can take a call when the maintenance is required. That also helps us to prepare some kind of investment plan or the capex plan for certain equipments at a particular interval and planning for that. So in that way, I think these are some of the tools which is available to have a better control over asset performance. Another is about when moving to the coordination and management of widely spread asset. I think the most important one is a remote control, because the substations are generally located in a hinterland at a rural area, but the management is at the some like corporate level, or we wanted to have some kind of a better control of our operations performance. In that case, remote control and common control centers is very, very important. And now with the help of transmission lines having OPGW, it is very easy to connect and integrate each of the substations. Like in case of IndiGrid, we have all 12 substations on all transmission line connected to our substations are centrally monitored, controlled, and operated from remote control center at Bhopal. So all the operation is being carried out. We are getting all the informations in terms of operational data, and all the alerts are also being generated. All the SCADA is integrated, and benefit is also that with taking care of various cybersecurity aspects, this network can be secured as well. So that we are working on that. We had a proper operational control and monitor of our assets. Coming to the sensorizations, there are a lot of technologies available nowadays catering to various equipments. When we talk about equipment like transformer, reactor, and then online DGA, online bushing, measurement, and monitor controls are available. As well, in case of increasing water content, technology like online moisture removal is also available. So this can be employed on the
Mr. Piyush.
And we have deployed some of the technologies that are available.
Yes, sir.
Coming to sensorization part of it, there are various technologies available from the OEM side, like online DGA monitor, bushing monitoring, as well as online moisture removal, which help into improving the health of the various equipment, mainly transformer and reactors. So these are also getting a lot of tractions, and many utilities are deploying that. At IndiGrid also, we had deployed some of this technology, and we are getting benefit out of it. Another challenge that not only substation, but as a overall transmission line and sector is facing is about vagaries of weather and climate change. To certain extent, it is beyond our control. But if we can get a better access of the informations, what is going to happen, with better predictability models. I think that is very, very helpful to plan our resources and also to mobilize our resources in case of emergencies. At IndiGrid, again, we had like in a subscription-based model where we are getting weather data and forecasting so that we can plan our maintenance schedules, we can calibrate our maintenance schedule accordingly, and proper utilization of and our resource mobilization can take place. So these are some of the technologies that we are working on that. Coming to last part of my this session topic, related to this session topic, will be on the design part. So when we, and on one end, there is a growing need of expansion of transmission network. But at the same time, main challenge the transmission sector facing is ROW, of getting a land or getting an access right to put up either transmission line or to build a substation. And this is very, very crucial when substation has to be built in some kind of urban area where land is very, very prime consideration, right? So in that case, nowadays, a new design has come up in terms of vertical substations, vertical GIS substations, which having a like a 70 or 60 to 70% footprint reduction if we compare to the similar size of 400 kV EIS substation. We at GPTL has like a 3 vertical substations near to the Gurgaon area, which is very, very populated and prime dense area. This substation, if we can imagine, is a 400 kV substation with 400 kV GIS at the ground floor, 220 kV GIS at the first floor, and 220 kV open switchyard at the top floor. And it is now this substation is built within a 3.5 acres of land. If we compare of similar size of substation of AIS, it will definitely require some kind of a 25-35 acres of land. Apart from that, the benefit of a pre-engineering fabricated structures that also add in terms of cost saving, time saving. So I think while we are having a lot of technology available, application of this technology, affordability of this technology, and upskilling of manpower, this is also important to get a better advantage in terms of productivity, reliability, and efficiency. I think one of the panelists talk about stakeholder engagement and collaboration of all stakeholders. What is noticeable in recent time is that Indian government is also pushing a lot of effort into that. And last year, one task force was formulated to make a blueprint for substations and transmission sector to become smart and future ready. And this task force has given a lot of recommendations, and we definitely hope that this recommendation will translate into actions going forward. And this will definitely becomes a transmission and substation a future ready and smart. Thank you.